कौन सी कितने बजे ना वो
Confirm. Upper 30. Yes, not 20. Not 20. Not 20. Not 20. No. Upper 20.
Good afternoon. May I request all the participants to kindly mute their microphone so that it will avoid unnecessary noises. Today, Department of Geology and Environmental Science, Christ College Autonomous, IRINJALAKUDA, Kerala, is organizing a webinar on geological outreach and career development with the theme of opportunities of an earth scientist in academia and beyond. The target group of the webinar is mainly students who wish to pursue higher studies in geology and those who wish to take geology as an option for their career. During these difficult times of COVID-19 pandemic, students and other stakeholders of academia and industry are confined to their own house or workplaces. So students do not get a chance for physical interaction to help them to make an informed decision about their choice of subject of higher study. Initiative would be helpful for students to interact with experts from academia, research, private and public sector, industrial undertakings. I congratulate Dr. Devi K, faculty of our department, in organizing this event along with other faculty members of our department. The 2 days webinar will be conducted on the online platform Zoom, and because of the large number of turnout from the registered participants, the lectures are also live streamed via YouTube. I'm sure the necessary guidelines have been reached to you for attending the program. Now, with this brief introduction, let me welcome the participants and delegates of today's workshop. Let me welcome our principal, Reverend Dr. Jolly Andrews, who will be giving the inaugural address. I also welcome the speakers of the program, Dr. A.P. Pradeep Kumar, Professor, University of Kerala, Mr. Arjun K.R., Reservoir Manager, Oil and Natural Gas Corporation, Mumbai, Dr. Bivin G. George, researcher at the Institute of Geological Sciences, Polish Academy of Science, Poland.
Ready?
Dr. Shraddha Band, Geoscience Division, National Taiwan University, Taipei, Taiwan. Dr. Ikshu Gautam, Earth and Planetary Science Division, Tokyo Institute of Technology, Tokyo, Japan. Mr. Nirup Shankarji, Senior Geologist Afcon Infrastructure Limited, Kolkata. Ms. Sidhu Soman, Senior Geologist, Geological Survey of India, Chennai. During these 2 days of interaction, you will have opportunity to talk to experts and resource persons from different walks of geoscience. I wish all students a useful interaction with the experienced resource persons that we have here for the interaction. We have about 600 participants from all over India registered through the link that was provided. And we also believe that a good number of participants may be viewing the program through YouTube Live. I welcome all the participants and viewers of this program to this event, 2 days program. With this, I welcome Dr. Jolie Andrews, the principal of Christ College Autonomous, for the inaugural address.
Okay, very good afternoon to everyone. Am I audible and am I visible to you?
Yes, Father, you are visible.
Thank you. Dr. Linjo Alapat, the convener and the HOD of the Department of Geology and Environmental Science, the eminent professors and the researchers and the scientists who are attending today's webinar. I would note Professor A.P. Pradeep Kumar, Arjun K.R., the managing reservoir from ONGC Mumbai, Dr. Bin G. George, Dr. Shraddha Ben, Dr. Ikshu Gaudam, Mr. Nirubam Shankarji, and Ms. Sidhu Soman, and a host of eminent researchers and the professors who are from the different parts of the world for coming together in order to explore the webinar, the 2-day international webinar on the geological outreach and the career development that has been organized by the Department of Geology and the Environmental Science and our very beloved faculty members. On the very outset, I would like to especially appreciate the Department of Geology and Environmental Science for coming together and making this 2-day international webinar on the geological outreach and the career development here possible. I especially appreciate the HOD and the convener, Dr. Lindo Alapat, Dr. Devi K, and all the faculty members of the department who are in this organizing committee for making this webinar a possibility. A brief note about our Christ College. College was started in 1956. The college was started in 1956 by the Devamada province of the Carmelites of Mary Immaculate, an indigenous religious organization founded in 1881 by Saint Chavara, a saintly priest and a versatile genius. And the college is dedicated to Christ and has as its motto Jeevita Prabha, which means the light of life. Now, this college is a part of the century-old tradition of CMI education. The college has present 27 UG programs, 16 PG programs, and 11 departments are offering the research. I'm happy to note that we have already signed MOUs with the University of Zululand, South Africa, and the Leibniz Institute for Applied Geophysics, Germany. And in this occasion, I especially want to make a note about Dr. Lindo Alapat, who has taken all the effort to make this MOU possibility. So I especially appreciate Dr. Lindo Alapat for this MOU. And the recent feedback that has been approached, that has been obtained by the Facebook, I'm happy to note that the Christ College has been adjudged as the best campus in the Kerala also. Now, the college has got a lush, green, beautiful, environmental friendly, having geological diverse campus here, and that will really help you a lot if you really actually come over here. And with these few notes, I would like to formally inaugurate this two-day international webinar. May this coming together help you all in order to explore the new ideas about the career development, especially in the geological frontier. May God bless you all. Have a wonderful time. Congratulations once again to the department. Thank you. May I remain.
Thank you, Dr. Jolly Andrews, for the inaugural address. Now I invite Dr. Devi K, who is the organizing secretary of the program, for introducing the first speaker of the day. Thank you.
Mute.
Good afternoon to all the listeners. Today we have talk about higher education and career opportunities by Dr. Professor A.P. Pradeep Kumar. He has completed his BSc, MSc in Geology and PhD in Metamorphic Petrology from University of Kerala. He was worked as a research assistant in University of Stuttgart in Germany. And he has worked as scientist at CGWB Bangalore. Since 2001, he was worked as lecturer in University College and Government College, Kottayam. After that, he was reader at School of Environmental Science, MG University, Kerala. Since 2014, he is working as professor in University of Kerala. Additional to all these, he is associated editor of Springer Journal, Spatial Information Research. I over to you, sir, Pradeep, sir. Please, sir.
Okay, I'll come online. Okay, can you please enable screen sharing?
Okay.
Please enable screen sharing.
1 second, sir.
Okay.
Yeah, is it, can you see, do it now?
Let me try once more. Oh, yeah, now it's possible. Okay, thank you.
Yeah,
I'll do it now. Okay. I hope the screen is visible and I'm audible.
Yes, sir.
Okay, good afternoon, all of you. I am Dr. Pradeep Kumar from the University of Kerala's Geology Department here in Trivandrum, Kerala. So welcome all of you from within Kerala and maybe from outside Kerala and maybe even from outside India. Anyway, a virtual welcome to all of you to this wonderful event being organized by Christ College through our inimitable Dr. Lindo Alapat. As we all know, he has been a force to reckon with in geology in Kerala as well as in India, and he has been doing the sort of seminars for quite a long time. Okay, and maybe some of the participants could mute their mics. That would be a good idea so that we can go ahead without much disturbance to the other participants. Okay, so today I thank the Christ College Untitled as well as Lindo Alapat and his team of teachers, staff, and students for inviting me, especially to deliver the inaugural talk. But this is no particular learned talk. This is just a, let's say, sort of chit chat on higher education and career opportunities in geology. So we will keep it short, maybe for 30 minutes. We will just quickly go through what's what in geology as far as studying and working is concerned. Okay. So we have to dedicate this talk. I have to dedicate this talk to students because without students, there would be no geology possible. Professors by themselves cannot do much. So it's definitely students who take the cudgels, do the work, and bring laurels to the department as well as to their professors. So I dedicate it to the students, and mentors also matter. Definitely mentors matter. But one thing we have to remember is everything matters, but you should work hard. Only then success comes in. So unlike in a dictionary is the only place where success comes first, followed by work. So we have to have work first and then success will follow. Okay. So our talk, we will go through some, what do you say, some of the locations where you could do a master's. What can you do after your master's? Then what about a PhD? And we'll also look at some success stories in between. People who have done well. Doesn't mean these are the only people who have done well. There are many people who have done well, but it's impossible to show them in a short PowerPoint presentation. So as you know, geologists look into all aspects of the earth. So we are involved in its surface processes, internal processes, its external processes, and in additionally, geologists are now also environmentalists too. They always deal with problems involving the environment through geochemistry, through disaster management, landslide studies, etc. Okay, and this is this diary always resides in the hand of a geologist, because without this diary there is no life. You take down your notings, you note down things using this diary. So all geologists are fond of carrying this diary around. So in short, this is the crux of geology. Okay, and the student after his +2 or after his bachelor's is at a turning point, and the turning point has got a lot of options. It's spread out the what to choose. That's a big question that rattles his brain. So what does he choose? Can he go for a job after his BSc, or should he go for an MSc in geology or an MSc in some other subject? Should the job be in Kerala, or should he study in Kerala or go somewhere else in India, outside Kerala, abroad, MSc in Kerala, MSc in India, or MSc abroad? All these questions come up in mind as soon as you are on the threshold of finishing either your bachelor's or your master's studies. But after your bachelor's, opportunities are pretty limited. As far as Kerala is concerned, opportunities are limited. I'm not sure about the opportunities in northern India. In Kerala, the Kerala Public Service Commission used to recruit BSc geology students as geological assistants in the Kerala Public Service Commission, but that has stopped. Now they do not recruit geological assistants. They directly recruit as assistant geologists based on their master's degree. Another place where you can go in as a BSc in geology is in National Institute of Oceanography, Goa, not in a permanent position, but in projects. So if you keep on looking at the website of NIO Goa, you might come across project positions advertised where they need technical assistance with BSc in geology. So these are some openings, but rare. And as far as studying in Kerala is concerned, there are several opportunities in Kerala to do a master's after a BSc degree. So if you are in University of Kerala, you could go to the university campus of the University of Kerala, which was established in 1963. You could do an MSc, you could do MPhil, you could do PhD. Then there is a college under the government, under the university in Trivandrum called the University College, where you can do an MSc. Then there are some self-financing colleges. There are two, in fact. The SN College, Varkala, has a self-financing master's program, and the Palpu College, this is a new one, also in Trivandrum district. It's a self-financing master's is available. Then if you look at Mahatma Gandhi University, you have a master's program in the Government College, Natagam. It has produced some excellent students, excellent researchers. In fact, our second speaker, Arjun, is a master's degree holder from Natagam Government College. Immediately after passing his MSc, he directly got into ONGC, much delay. Maybe the same year he was employed in ONGC as I think as a reservoir geologist or so. Then we have the only places offering marine geology and marine geophysics, that is CUSAT. Cochin University of Science and Technology in Cochin is a good destination. Now they have excellent teachers. A young crop of teachers have joined the department, and it's also now recognized as a Polar Research Center in association with the National Center for Polar and Ocean Research in Goa. So this is a very happening place. I would say in the whole of India, CUSAT Geology department is a very happening place, marine geology, marine geophysics. So it's a good option for BSc students to go in, especially if they are interested in research. And as far as geophysics is concerned, if you finish a master's in marine geophysics, there are plenty of job openings awaiting you. Then Calicut University, you have the university campus, which is a new one, a new department, but again a master's in geology, which is in the self-financing mode. Then you have a bit old master's in applied geology in the MES College, Ponani. They also have a good lineup of faculty with expertise ranging from hydrogeology, remote sensing, GIS to core petrology, metamorphic petrology. So you could do a PhD also there. Then you have our very own host, Christ College, IRINJALAKUDA, where also you can do a PhD. There are around 6 departments in Christ College, which are research centers where you could do a PhD. And in geology, I believe Dr. Lindo Alapat is the only guide. I'm not sure, but probably he's the only guide in geology in Christ College, IRINJALAKUDA. They offer a master's, which is in the self-financing mode. In Kannur University, in the Government College, Kasaragod, quite an old department where you do your MSc Geology as well as PhD. Then the newest one is Central University of Kerala, again, where you have an MSc and a PhD program. So these are the opportunities within Kerala, pretty good places to go and study. Okay, and let's see one guy in between. This is Sharath. Why I showed him here is, when you look at this, what you see is he studied economics, history, politics, and geology. Those who are attending from outside Kerala might be surprised that he did this in his +2. So in +2 in Kerala, it's possible to study geology. Geology could be studied in different combinations, and there are some schools in Kerala which offer this combination. And Sharath is one person who studied it in combination with humanities, economics, history, politics, and geology. But that did not prevent him from becoming a geophysicist in Fugro. So what you studied in your +2 need not hold you back. He learned all the mathematics and all the physics and all the chemistry he needed while he was doing his BSc Geology in Kannur University in Kasaragod. But he had no math still. He went on to do his MSc Geology from Central University of Kerala, then finally ended up with an offer as a geophysicist in Fugro. So I show him because your background need not hold you back from getting into a job you think is unamenable to you. It might really be in your arm's length. You can grip it. Okay. And after +2, there are possibilities of MSc integrated. You do a BSc along with an MSc. So after +2, you could go in and do a MSc. It's possible at several places like Bharathidasan University, Pondicherry University, Annamala University, and in all these places like ISER Kolkata, ISER Pune, ISER Bhopal, and IIT Kanpur, not in ISER Mohali. All these places you can do a direct master's, which is a combined BSc, MSc program. So you could go in after your +2. And what are the advantages of going in after +2 into a master's in earth science or geology? The advantage is you get to learn your bachelor's in a highly research-oriented environment. So you get an opportunity to be part of research right from your first semester. And you will have excellent teachers like the one listed here from ISR Pune, where we have specialists from across the spectrum of geology: paleobiology, earth science, climate dynamics, stable isotope geology, earth and climate science, weathering and erosion, rhenium, osmium, geochronology. So you have several specializations in one department. The student definitely will gain from this. And additionally, there are meteorology specialists also. You can see 2 meteorologists here, Suhas Ettamal and Nina Joseph Mani. Both of them are MSc Meteorology graduates from the Cochin University of Science and Technology, and subsequently they went to the Jet Propulsion Lab in USA and had their PhD in different universities in USA, and they are now in ISER. So ISER gets the best amongst the faculty to teach their students. So that's ISER Pune. And in ISER Mohali, there is no MSc Earth Science or Geology, but you can do a PhD in Geology. That's always possible in a lot of different specializations. So it's a good location to do a PhD in ISER Kolkata. And the ISERs have got special programs with software suppliers. This is a suite of software, Move suite, really expensive, used for modeling and programming a variety of geological environments, from structural geology to petroleum geology to environmental geochemical modeling. So these suites are available for students. And again, we come to a profile. This is Dr. Anoop Ambli. It might not be very clear here. Anoop Ambli is a professor in ISER Mohali. He did his bachelor's in University College Trivandrum, MSc in Pondicherry University, and finally a PhD in Geoforschung Zentrum, Potsdam in Germany. The best center to do a PhD in geology in Germany is the Center for Geoscience Research in Potsdam, Germany. And finally, he ended up as a faculty member in ISER Mohali. So why I showed him is to motivate young students, meaning that I had taught him in his BSc in University College. So from there, he went up step by step, went to Pondicherry University and then abroad. Pondicherry University is a springboard for many students. There are a lot of success stories coming out of Pondicherry University. I talk about Pondicherry University because I am familiar with it. There are other places also. Okay, and if you are looking for options outside Kerala, then one of the best options is to write JAM. After your BSc, you could take the JAM exam. And you could go into an MSc in geology or applied geology, or you could also go into a integrated geology program. Integrated geology program is available after BSc in IIT Bhubaneswar is one place. Integrated BSc MSc is available after +2 in IIT Kanpur. Okay, this is as far as IIT Bhubaneswar is concerned. Around 25 seats are also available. You have to write JAM with geology. If you write, and there is also a course called Atmospheric and Ocean Sciences, which also geology students could apply for. Always a question comes up whether I should study geology after MSc or should I go for some other subjects. You can go for other subjects if you are really interested in research, because if you go for some subject other than geology, the job opportunities available in geology will not be open to you. You cannot write the UPSC combined geologist exam. You cannot go into ONGC. You cannot go into AMD. So you will have to think about it, and you will have to think about your interests before you decide on a course other than MSc in geology. So this is the IIT Bhubaneswar website. IIT Bhubaneswar is a relatively new one. It's in Bhubaneswar, and they have an MSc program in geology also. So they offer an integrated as well as an integrated MSc PhD program is also offered. Not all MSc students can directly get into a PhD. There would be a process. Okay, so again, you have an atmospheric science faculty here who is again an MSc in meteorology from the atmospheric science department of Cochin University of Science and Technology. Okay, and how do you choose the IIT? Or how does the students all over choose IITs? Which IIT would they choose? Definitely the first choice is IIT Bombay, because the first ranker had chosen IIT Bombay, and the last rank getting into IIT was 16. Then the second choice was IIT Kharagpur, third was IIT Roorkee, fourth was IIT Dhanbad, previously Indian School of Mines, and then IIT Bhubaneswar, naturally being a new one, that was last in choice with ranks like 89 and 119 for atmospheric science. Okay, so IIT Bombay at first position is the choice for MSc Applied Geology after JAM. And this is a young lady. I just showed an example to show that it's all possible. She has just now got admitted in IIT Kharagpur after her BSc from the University College Trivandrum. So ISR Calcutta has an integrated PhD in Earth Science. ISR Mohalli has a PhD in Earth Science. This is the old Bengal Engineering College, which has now been renamed the Indian Institute of Engineering, Science and Technology. It has also got a MSc in Applied Geology as well as PhD. It's in Shibpur in Calcutta. So not an unapproachable place. You can also get in there if you write an entrance exam. And this young lady here, Asia, is going to join this university or this place for her MSc after her BSc from University College. So she will be joining shortly, probably. And there are plenty of places where you can do your MSc Applied Geology in South India. This is just about South India. Places in North India abound. So this is very dear to us because Anna University is the place where our host, Dr. Lindo Alapart, did his master's. School of Earth and Atmospheric Science is the place where our Dr. Lindo Alapart did his MPhil. So this must be excellent places to study because it has produced an excellent geologist. Pondicherry University is also equally good. Several excellent students and scientists have been produced, and there are very many places where you could do your master's studies. And there are some courses which are not called geology. They could be termed earth science and resource management, different terminology, but it doesn't matter really if you are writing the UPSC exams. UPSC is very broad-minded. They allow all sorts of subjects as qualification to write the combined geologist exam. But when it comes to the public service commissions, they are a bit hesitant to recognize these courses as equivalent to geology. So you might have some problem if you go and take up a course like earth science and resource management, and if you try to get into a job through your local public service commission. So that you have to be careful. And there are several central universities in South India which have got geology, and the latest one is, you might probably know, Tamil Nadu University, located in Tiruvarur. And there are NITs, Raipur, Rourkela, etc., which have got MSc Geology. Raipur has a 3-year MSc Geology. So this new department in Tiruvarur has got some new faculty members. And amongst them is one of the alumnus of Government College Natagam in Kottayam. She did her BSc in Government College Kottayam, then went on to do her MSc in Applied Geology from Pondicherry University, then her PhD from IIT Bombay in Metamorphic Petrology. So she is one of the new faculty members in the newly formed Geology department, which started functioning in March 2020. Okay. So you can do an MSc anywhere in India or in Kerala or in the world, but to add value, you need to have some additional skills or additional qualifications. One way to acquire additional qualifications is to do summer internships in any of these places listed here, like Indian Academy of Science summer internships, in CSIR labs, NGRI, Wardia Institute, any of these places. You could do a 2-month summer internship. It will add value to you. You could do short-term association programs with GSI, CWE. GSI, in fact, encourages these. You can do your master's thesis in one of these organizations. You could attend seminars. You could present papers. You could be part of a Bhuvi Samvad program of GSI. So there are many opportunities. Why you should do these things is, if you attend some of these programs, your personality will change. You will have a better understanding of how research is done, how professional organizations work, and also additional advantage is that your professors can easily write recommendation letters for you. They can say that, okay, this guy or girl was very good in his studies. Also, she or he was outgoing. She did an excellent internship with this institute in this subject. Her master's thesis was done very well. She presented a paper based on her master's thesis in this particular seminar. So it adds value to your CV and gives confidence to your professors to recommend you for PhD positions or for jobs. So then there is a possibility of doing online courses like NPTEL courses conducted by the IITs. This is a course conducted by IIT Kharagpur, Fluid Inclusion Studies. It is done by an excellent economic geologist in IIT, and the best thing is they conduct an exam. If you want to write the exam, you can write the exam in your own state, and they give a certification and they also rank. So this lady was ranked first. She is now a PhD scholar in fluid inclusion studies in Center for Earth Science Studies. She did her BSc in SN College Chembaranthi and subsequently her master's in Central University, Karnataka in Gulbarga. So anyone can do this NPTEL course. Right now there is a course about to begin. It is in IIT Kanpur on photogrammetry and image interpretation, offered by Javed Malik, an expert. So it's free of cost. You can go to the NPTEL website and you can register for the course and attend the course at your leisure. If you want to write the exam, you have to pay 1,000 rupees and take the exam at the end of the course, and you get a nice certificate like this. An excellent certificate like this you will get. Okay, something like this with the IIT logo on it. And you could attend Bhuvi Samvad courses. It's taking place all over India in different departments. So make it a point to attend. This is just an advertisement of one which took place in MES College, Ponani. Okay, this question we addressed. And another question is, should a BSc physics or maths or chemistry guy come into geology or geophysics? I would say definitely. They have a very good opening in geology, especially if a physics or chemistry or maths guy goes into MSc marine geology or MSc marine geophysics. He could get into very specialized areas where his mathematical and physics skills combined with the geology he learns during his master's program helps him get into some positions which normal geology people are unable to get into, where very specialized mathematical and programming skills are required. Most of these master students with a mathematical and physics background are able to gain a lot of programming and mathematical analytical skills. So I would suggest many of the physics and maths people to maybe go into geology and geophysics. And this is what I said. The qualifications to write combined geologist exam, UPSC is very liberal. You can have a master's in geological science. You can have a master's in oceanography, earth science and resource, petroleum geoscience, geophysical technology. Anything makes you eligible to write an exam for recruiting geologists. What about ONGC? ONGC is a bit conservative. They say that you must have an MSc in geology and either maths or physics as one of the subjects in the BSc, not both, either maths or physics. Okay, if you want to become a geologist or reservoir engineer in ONGC. And if you have GATE, it should be in the geology section. This is about GATE. Okay. And if you want to become a geologist in ONGC, again, you need to have a master's degree in geology. No earth resource technology, or things like that. Earth resource technology will not be taken in. But MSc Petroleum, MSc Petroleum Geology is accepted. And you need to have a GATE score in the geology part. Okay. And when is GATE exam? GATE exam is coming up soon. It's staggered over many dates in February. Definitely you have to write and write the GATE exam. The best thing about GATE now is BSc students can write GATE. From this year onwards, third year BSc students can write the GATE exam, but they cannot get into an MTech or PhD until and unless they finish their MSc. So it's a good idea to start writing GATE even when you are in your third year of BSc to get an idea about how GATE is. And if you qualify, the GATE score is valid for 2 years. So probably it will be valid even when you pass your MSc. So you could directly get into an MTech or PhD in any of the IITs with a GATE score you obtained while you were studying in your BSc. So start right away. And many of the public sector undertakings like ONGC, Mineral Exploration Corporation Limited, all of them are starting recruiting only through GATE, Atomic Minerals Division. Shortly after some time, GATE will become a test not for scholarship, but for employment also. If you look closely at the GATE this year, you will see that commerce and humanities have also been included in GATE. Why? Because you need human resource guys in public sector undertakings. They will recruit through the GATE score obtained by people with commerce degrees and arts, English, sociology degrees. So it has become a pan subject exam now. So GATE has a lot of weight. You should prepare for GATE. It carries questions of a simple nature to a slightly complicated nature in the subject and in general science. And you have very involved questions, testing your analytical capability, testing your integrative capabilities, memory, and real analysis also is needed. Okay. And coming to CSIR, if you score very high marks, you get very good scholarships through the Shyama Prasad Mukherjee Fellowship. But to get into a CSIR lab, you again need to apply for admission for PhD in the Academy of Scientific and Innovative Research. This is something which has been brought about by the CSIR labs, consortium of CSIR labs. So you cannot apply to NGRI, you cannot apply to NIO, you cannot apply to Indian Institute of Tropical Meteorology or places like that. You have to apply to ACSIR. Then they will allot to the different places. So with many of these fellowships, you can apply. For instance, in Goa, you can apply with CSIR fellowship, UGC fellowship, and you can apply with these two fellowships, but not with GATE. GATE is not accepted by NIO Goa. Inspire is the fellowship given to first rank holders in MSc. That is also not accepted by NIO Goa. So you have to look really into the qualifications. Only CSIR is allowed into CSIR and UGC in NIO Goa. Okay. What about Birbal Sahni Institute of Paleosciences? UGC, CSIR, and Inspire. No GATE. GATE is closed. As far as some of the CSIR labs are concerned, the GATE is closed to GATE. Okay. What about NGRI? Excluding GATE. They don't like GATE people at all. They like only CSIR, UGC, DST guys and all. So if you want to get into CSIR, you have to study for CSIR, qualify CSIR and UGC. GATE is no. They won't open the gate to you. You are outside. With GATE, you can go and enjoy your life in some of these nice IITs. Or you can go and work in a top-notch organization like ONGC. So we have exhausted all our opportunities in India and in Kerala studying and doing all these things. So what about going abroad? If you want to go to USA, you definitely have to write GRE and TOEFL, but that is changing. Now many universities in USA have stopped asking for GRE. Now is the time of George Floyd. A lot of changes are taking place. So many universities in USA have stopped asking for GRE because GRE decrease the most privileged people get through GRE. Okay, so maybe we'll stop in a few more minutes time. And then there is Germany. If you go to the DAD website, you get a lot of information about GRE. You can go to the Educational Testing Services website. This is one scholarship which is available for master's studies as well as for PhD, Erasmus Mundus in Europe. It is always listed which are the master's program, what is qualification. So there are India-specific scholarships, there are Asia-specific scholarships. Take a look at those. Belgium, go to this website, Willy Ross website. You can see a lot of scholarships getting published. NUFIC website for Netherlands scholarship. Similarly, for each of the European nations, they have their own scholarship websites, as well as this Erasmus Mundus website. And Japanese scholarship is amongst the best scholarships. So this is one of those scholarships, which is a tongue twister. So don't try to read it, only learn the spelling and write it down. Mombuka Goku Sho. So you go to the next website and you have an excellent website describing all these. And if you are confused about where to study in USA, you can go to the US News and World website where they list each of the universities by subject, by ranking. Geology, which is the best. If you take a look, you will find that Caltech is the best. California Institute of Technology is listed as the best in geology, and it is followed downward by many universities. And this is about that many of the universities are dropping GRE. So you can read about that in the internet. In the EOS, you can read, or many places, you can read about that. And these are some of the places where GRE has been dropped. Boise State University, even the Johns Hopkins University in Baltimore has dropped GRE. not required. Cornell University doesn't need GRE. So GRE is optional in Boston College. So there are many places where GRE is not needed. Now I'm not going to go deep, going to list out all these things. These are the places where job openings are available, but I will not read through it. There is no point in reading through it because this is well known where you could get into. So I'm just showing this. Maybe the slides, the recording will be shared with you and you can take a look at it. So many public sector undertakings, when you say public sector, immediately gate, SAIL, gate, Hindustan Singh, gate. So gate and this is now closely interlinked. All these places, gate. And there are some good websites which give you information. Earthworks-jobs.com is very well known, so it's very competitive. Everyone in the world knows this website. If you want to get into academia and research, highereducationjobs.com, higheredjobs.com. Specific to USA, you have to go look into this website, findajob.cgu.org. And this is the website to go if you want to look at the salaries. What salary will a new geologist get in a soil testing company in the Gulf? Go to glassdoor.com and you can get the salaries and also vacancies available. Okay, we are almost at the end of the program. My talk will finish in the next 1 or 2 minutes. I'm just showing some profiles. This is a guy, Aravind, who did his BSc in University College, then was MSc in IIT Bombay. Now he's a scientist in AMD. So he was in Associated Cement Company and DBS, the Diamond Exploration Company. So you see that job opportunities exist in cement companies and in diamond exploration companies also. So BSc, University College, MSc, IIT Bombay, and scientist in AMD, that's Akhila. Then you have Raisi, who is a postdoctoral fellow in Physical Research Laboratory, BSc SN College, Varkala, MSc in University College, and PhD from Anna University. Then this guy here, Ruju Stephen, BSc from University College, MSc from University of Kerala in Trivandrum, and MSc Geoinformatics from the Baylor University, Texas in 2001. He was a geologist in GSI. He wrote the civil service exam and became a senior superintendent of posts in the Indian Civil Service. He quit that job and went to study MSc Geoinformatics, became a GIS analyst for the city of Houston in USA for 10 years. Then came down to Iraq and is a GIS migration analyst in the United Nations, the Institute of Migration. So there are similar such people, which I am not going to really talk about. So these are all success stories which began from a very low level. And finally, we have our own experts here. This is Tamban Meloth, who is a Group Director of Polar Science in the National Center for Antarctic and Ocean Research, BSc Geology from Kasaragod, MSc Marine Geology from CUSAT, PhD from NIO Goa and University of Bremen in Germany. And another German PhD is here, our very own Lindo Alapad, BSc from Christ College, MSc from Anna University, MPhil from University of Madras, PhD from the Freie University of Berlin, Germany, and then PDF in PRL Ahmedabad. And also one more guy from Christ College. This is not fairly well-known person. This is Mr. Let's see who it is. This is Naushad. Naushad is from BSc from Christ College, MSc from University of Kerala, and PhD from Montclair State University, USA in 2006 or 7. And he's a faculty in the Montclair State University. And with that, we come to the end of this talk. Thank you for your patient listening. And I hope I could convey some information on studies and job opportunities. Thank you. So we stop here.
also choose a plantation based on your understanding and survivability.
Thank you, sir. May I now invite Mr. Tarun R. to propose vote of thanks and introduce the next speaker? Tarun, are you around?
How long it will be, what will be the height?
Yes.
How interest as a so
Professor Tarun.
So good afternoon to all participants, and thank you, Dr. A.P. Pradeep Kumar sir, for his very informative talk. And I am sure that this particular talk helps the participants to visualize what all opportunities are in front of you once you have completed your studies. So I once again thank you, Dr. Pradeep Kumar sir, for
Thank
this
you.
very informative talk.
Thank you, Tarun.
So
Thank you.
Tarun,
our
maybe if we have
next speaker is
Tarun?
Mr. Arjun KR from ONGC. And the small introduction about the speaker. He had joined the ONGC as a reservoir engineer in 2010, or soon after completing his MSc Geology from the Government College, Kottayam, in the year 2010. And he had worked in the area development team in Mumbai High Asset and also worked in offshore for carrying out various pressure temperature studies. And presently, he is working as a manager in the interpretation team of the pressure transient test in the ONGC field in the Western Offshore Basin. So I welcome Mr. Arjun KR into the webinar and wishes the participants to have a fruitful session. Thank you.
You can always think that whatever the test you are doing, these tests have a certain meaning and certain a type of you can be benefit in your study. Otherwise, the test should not be just like a protocol test, and that will be not going to help any kind of knowledge.
Okay, thanks. Okay, am I audible?
Yeah,
Yes,
yes.
Arjun. Yes.
Okay, just
Actually, 1 second. May I interrupt Arjun for a second?
okay, okay.
We had missed the question and answer session for Dr. Pradeep.
Okay,
I
fine,
think
fine.
that may be done after the presentation from Arjun. So we can combine it and ask. So I request participants to kindly reserve your questions. And Professor Pradeep Kumar, he will be taking up the questions afterwards. Or you may
Yeah.
also contact him through email, isn't it, sir?
Yeah, sure, sure.
Okay, thank
I'll
you very
be
much.
here.
All right, thank you very much, sir. Now, Arjun, you may continue. Thank you.
Okay, thanks, Pradeep sir. He was my he taught me metamorphic petrology in Kottayam, Government College, Kottayam. So, I welcome all you to well-set geological operations. So actually, a well can be classified into three. First is exploratory wells and development wells, utility wells, and an appraisal well. So exploratory wells are drilled for just exploration purposes, and development wells are drilled in an already established geology. So we know the geology of a development well area very much better. And the utility wells are sometimes drilled for some other purposes like a relief well, etc. And we have appraisal well. Appraisal well is is a type of well, and that is drilled to appraise a particular location before the commencement of economic production from that area. So this is the brief sketch of a well. So first we lower the conductor casing, then slightly bigger, slightly smaller intermediate casing, then intermediate casing again. Then we will be lowering the production casing. And this is the area of interest, and we will be doing perforations here to produce oil or gas, whatever it is. This is a classification of wells. Based on profile, we can classify wells into vertical well, deviated well, and horizontal well. So vertical well is just, it will be a vertical, and they have TVD and MD. Total true vertical depth and measured depth will be same in this case. In a deviated well, the MD will be higher because it is going at an angle, and the true vertical depth will be small. So this is a horizontal well. This type of wells are drilled in a location. We are quite familiar with this kind of formation, what type of fluid is coming and all. So we can drill a very long horizontal well. This is around half kilometer. We can drill like this to produce oil. So this is a multilateral well. This is a new technology well where we can branch wells like this. One will be going in this zone, one will be going in this zone, another in this zone, like that. So as a geologist working in a field, a geotechnical order is of utmost importance. It is actually the pre-planning of a well. It contains many informations regarding regarding what type of formation will be that, and what type of mud will be used in that drilling, and collection of any issue will be coming in that well, like any type of mud loss will be occurring in that well, etc. So, and this is generally made by geologist, driller, and chemist. These three people work together and come up with a geotechnical order. So it incorporates the expected lithological sequence and stratigraphic reservoirs. So this is a type of GTO. And you can see this is the stratigraphy, proposed stratigraphy, and this is the geological and geophysical data here, and we can have mud parameters. What type of mud will be used in the drilling, and this is the drilling data. What type of bit will be used in the drilling, and this is the roughly planning. How many days it will be like 36? It will be taking around 5 days, and 17.5 inch hole will be taking around 7 days, and it also contains many geophysical seismic sections. It is a rough plan on how that well will be drilled. So coming to a well-set geologist, so these are his duties. He has got many duties on well site, and he required to monitor vital operations, and he had to carry out formation evaluation. So formation evaluation is nothing but the analysis of the subsurface formation characteristics. So he had to carry out formation evaluation by using logs, various logs that is being recorded while drilling, and many other geophysical inputs. So we can just classify well-set geology into these parameters. His duty: evaluating drill cuttings, evaluation of hydrocarbon flows. And during the drilling, he had to monitor many things, and during the mud logging operations also he had to monitor many things, and coring, and during the logging operations. So these are the 6 primary duties of a well-set geologist. So first is the drill cutting evaluations. So as we studied during the MSc and all, we had to define whatever the cuttings in what type of rock is coming, classification, color, luster, and many parameters. We had to classify those cuttings. Cuttings are nothing but rock fragments that is broken from penetrated rock during drilling operations. So shale shakers, desanders, desillators, we can find the cuttings, and a geologist has to examine those cuttings and to note down his findings. So sometimes we have to ship the samples also for government requirements, future reference library samples, etc. So these samples are normally, the cuttings are examined every 10 meters during the initial phase of a drilling, and every 5 meters during the zone of interest. So second thing is the evaluation of hydrocarbon shows. First is the oil shows. In oil, we can go for these 4 parameters: hydrocarbon order, oil staining, natural fluorescence, and solvent cut fluorescence. A geologist has to examine these 4 things and note down his views on this. So first is the hydrocarbon order. Hydrocarbon order is it is a primary indication of the presence of oil. You can just smell it, like if it is, this gives just primary input regarding the hydrocarbon in that particular cutting. The general terms for describing hydrocarbon order is faint, moderate, strong. This you can characterize a particular type of sample. Second is the oil staining. The oil staining in a particular sample is actually a function of the porosity and the oil distribution within the pores. Simply, if the well is very porous, if the sample is having high porosity, it will be having higher oil stain. Hence, it can be also be like described in sticky oil stain, patchy oil stain, uniform oil stain, like that. Next is using the presence of identification of hydrocarbon shows using UV light and fluorescence. So all these cuttings are to be viewed under fluoroscope. So for the natural fluorescence, we have to carry out all these observations very quickly, because the fluorescence may lose due to the evaporation of the volatile fraction in the oil. So decreased intensity and darker colors commonly accompany decreases in API gravity of the oil. So decreased intensity and dark colors in a sample indicates that sample is having an oil API gravity of less. The degree of fluorescence may be noted as none, spotty, streaky, patchy, uniform, and a combination of these things. So this is the fluorescence indication of API gravity. Like if it is 15 to 25, will be having orange color, 25 to 35 yellow to cream, 35 to 45 white, 45 greater than 45 blue white to violet. In Mumbai, we are getting around a fluorescence of yellow color, which indicates the API gravity is somewhere around 35. Again, these are not hard and strict findings. These are just observations. Actual API gravity will be analyzed in the lab or in the rig by chemist. These are just a qualitative analysis of the sample. So next is the solvent cut fluorescence. The problem with natural fluorescence is that sometimes minerals also show fluorescence. So we'll be confused. So in order to avoid that, a cut will be putting this sample in a solvent, and the oil is separated from the sample, and the fluorescence is observed. So cut is nothing but the oil liberated from the drill cuttings when a solvent is added. Solvent, normally we use chlorothene. Solvent cut allows detections to be made regarding the mobility and reservoir permeability. Like I said, if the oil is going out from the particular sample very quickly, it will be having high oil mobility and reservoir permeability. So a cut is described in terms of its natural color, fluorescence color. So the cut speed in which the solvent cut occurs yields useful information. The speed can vary from instantaneous to very slow. So if the cut speed is very high, we can roughly say that the formation is having a good porosity and permeability, and oil mobility will be also high. So mineral fluorescence will not leach in a solvent, therefore no cut fluorescence will be observed. So this is to just identify having fluorescence effect. You just that we have seen here, natural fluorescence. Some minerals will be having natural fluorescence. So to eliminate that, we'll be doing this cut fluorescence. Next is how to identify gas source. Gas source, actually the extracted gas from the oil is drawn into the mud logging unit, and where it is measured by a variety of gas detectors. Usually there will be a hydrocarbon detector, a chromatograph, and a CVT detector, and an H2S detector. All these values are very important, because all these values will be used in the PVT analysis to measure the bubble point and like that. So in the evaluation of hydrocarbons, the mud loggers and well-site geologists will be working very closely and comparing the results, and these will be comparable, and then they will be helping each other to actually make all this mud log and all. Next is drilling. A well-site geologist is primarily concerned with those affecting drill string and the mud system. He is not worried about how much fast it is drilling, how much days will be taking. He is actually worried about the mud system, because mud system can actually damage the formation. If the mud is of higher density, then it will go into the formation and it will choke all the reservoirs. So these are the various drilling parameters: bit type, weight on bit, rotary trot, and mud density. So nowadays we use a measurement while drilling. All these parameters like inclination, azimuth, tool face, and all these are measured actually very quickly from the drill string. As soon as the drilling is going on, we get all the data live into the computers. So technology is so advanced. We get all the inclination, azimuth, tool face, and even logs. We get gamma ray logs and everything at the same time. So in the drilling parameters, one of the main thing is to look is to the rotary speed. Actually, the rotary speed, the general relationship between rotary speed and drill rate is that the faster the RPM, the higher will be the drill rate. It is just like that. And however, there is an inverse relationship between rotary speed and formation compressive strengths. With higher rotary speeds in soft formations, and there will be a hard formation, there will be a small speed. It is just because of the compressibility, compressive strength of the formation, that in the soft formations, the drilling rate will be high. In the hard formations, the rotary speed will be very small. So in the hard formations, it will take some time to drill, especially the granite, the basement rocks. It will take some time. So next in drilling is the weight on bit. That is actually the amount of weight that is added on the bit. As I said, the torque, the rotary speed is something similar to rotary torque also. The load torque values are observed in soft formations. Medium torque values are like somewhere between medium and hard formations. And erratic torque readings indicates the bit is undergauge, that the bit size is small, and the reaming of the stabilizers. Stabilizers means these stabilizers keep the drill string stable in a particular drilling hole, and it can also indicate some interpreted formations. So we expect constant torque values, and otherwise if there is any difference in the torque values, so these are some of its indications. Next is the mud density. Actually, as I said in the beginning, mud density is of utmost importance. If the hydrostatic pressure is greater than the formation, then flushing of the formations will take place. So mud density has to be very much similar to the reservoir pressure. If the mud density is more than the reservoir pressure, then mud will go into the formations and choke into the formations. And if the mud density is less, then fluid will come into the fluid will come and mix with the mud, and it will create all sorts of problems. So we have to be very careful in the mud density and the controlling the density. And viscosity has an effect on the next factor is the viscosity factor. It has an effect on cuttings recovery. So if the viscosity is higher, we will get more cuttings. But we cannot increase the viscosity. Actually, the viscosity is also a factor of density. If we increase the mud density, then viscosity will also increase. But we cannot increase the viscosity for just getting the cuttings. If we increase the mud density, then it may go into the formation as well. So it is very tight play. So next is the mud logging operations. Mud logging is actually a contract service in ONGC, and many patients from it is actually outsourced, and people will be stationary in the rig only. They will be carrying out the mud logging operations, and much of the information needed by the well site geologist is provided by the mud logging unit. So this is a sample of a mud log. So this is the rate of penetration, you can see, and here it is a depth. This is the cuttings percentage, and this is the fluorescence. This is a total gas unit, and this is the gas chromatograph, which is showing the quantities of C1, C2, C3 fractions, and this is the mud weight, and this is the lithological descriptions. Like description of sandstone, how it is, the shale sandstone. So next we come to coring. Actually, core is a sample of reservoir rock captured during drilling using an individual core is typically a few inches in diameter and up to 30 feet in length. Mostly we collect core of around 1 meter. So this is a core cutting bit, and this is that particular core barrel. The core goes into this drill pipe. So a core allows quantitative measurement of the following. Earlier we were having just qualitative measure of porosity, permeability, and saturation with that initial examinations, but coring will give you the exact value of porosity, permeability, and saturation in a particular core. But this requires very lab studies, and it will take some time to get all these values. So the secondary importance of coring is to identify the formation boundaries, large scale sedimentary structures, and any paleontological data if there is any. So to recover core, there are many types of drilling, which includes conventional coring, diamond coring, wireline coring, and sidewall coring. So in conventional core, as I said, and this will be the core cutting unit, and the core will go inside this barrel. And we can increase the length of this barrel by adding more barrels. So this is a diamond core. It improves the penetration rate because it is having industrial diamonds at its tips. So it can it is similar to the barrels used in conventional coring. So next is the sidewall coring. Sidewall coring is normally done in soft formations. So where you need a factor of horizontal permeability also. Normally we go for any microfracturing or intergranular arrangements. We use sidewall coring. And normally it is percussion type. We will get an idea of the horizontal permeability from sidewall cores. So how these cores are packed, and it is to be sent to the lab for examinations. Actually, this is a very important thing. Not only collecting the core from the reservoir, but it has to be packed, it has to be labeled in a very standard format so that everybody can understand. So if it is not, if it is if it is written wrong information on the core, then it will be the geology will be in trouble in that area. So this is very important. Arrow showing the up are drawn on the two lines. So an up arrow is normally drawn on a core, indicating the top of the core. So this is a well site core report. So you can see the depth, 1 meter core samples are collected, segment number, segment length, and lithological profile, and description of the formations, shale, and this is coal, again coal, and if fluorescence are also indicated if there is any. Next is witnessing wireline logging runs. Actually, logging is done by logging services. So a geologist has no authority in their studies. Logging is done by logging services only. So they will record the log and give us a result. So we can choose the area of interest zone to complete that well. Measurement that is plotted against depth. So this is a normal log. Is having gamma ray on the first track and resistivity on the second track, and the density, neutron porosity on the third track. So nowadays, logging while drilling technique is deployed in almost all wells. So we will be getting the real-time logs of the wells. So as soon as the well is drilling, we'll be getting its log in our computer screen. So some specialty logs like nuclear magnetic resonance that can give idea regarding the fluids in the log, and the imaging logs that imaging logs with the 360 degree so that we can place our well in the exact formation we desired. So as a whole, a geologist is responsible for a safety aspect during logging process, meeting the data requirements of the wireline logging program, organizing personnel and equipment logistics, data accuracy, accurate records of events during logging operations. So apart from his routine geological duty,
Participants can ask their doubts. Professor Pradeep Kumar sir and Arjun KR is available now to clear your doubts about this presentation. We have one question from Nigil Nair S. Nigil, can you ask your question, please?
Oh, my question is to Pradeep, sir.
Okay.
Yeah, yes.
Sir, am I audible, sir?
Yeah, sure.
So, while applying for the PhD programs abroad, should we first contact the university or the sir we are trying to apply under?
Usually you contact the professor you want to work with. So you directly contact the professor and establish a communication with him or her. That is the way it is done.
So what about the scholarship?
Then he will inform you about the availability of scholarships and things like that. Usually American and Canadian universities do not advertise the scholarships. Scholarships mostly are provided by the professors themselves, unlike in the United Kingdom. So it is always best to email not just one professor, maybe 2 or 3 or 4 professors, tell your interests, and slowly they will inform you about any scholarships that would be available. So you start by writing to the professors first.
Thank you, sir.
Okay.
Chiranjeevi Patnaik have one query. Yes, you can ask.
Good afternoon, sir. So this is
Yeah.
Chiranjeev Naik.
Yeah.
Sir, recently last year only I have qualified for GRE and I have got an opportunity to study in Canada for 4 years, MSc in MTech in Petroleum Geoscience.
Okay.
Sir, it is offering jobs after 4 years, like in petrol related companies and in like Iran, Kuwait and all. Sir,
Okay.
many are saying it is good and some are saying it is not good. Like after I am now pursuing MSc last semester. After that, I am going to go there. Sir, shall I join there or I am in a dilemma? Like I shall go
You have to pay a fee.
Sir, actually, I have it is around 1.2 crores. I have already got the scholarships and all. That is not the issue. But I am really confused. Like I should wait here to prepare for some other entrances, or I will go there because it is giving lifetime changing opportunity. Like if I go there, I will get a definitely good job. My seniors has also gone, but they are opposing me like to go there or not.
It's 4 years long, right?
Yes, sir. 3 years of MTech and 1 year of training. Like which company it will give.
If everything is covered and your expenses are not too much, then I would suggest that you take it up, because such opportunities do not come always. And
Like
once you are trained,
so some teachers are saying like that you should remain back and you should prepare for GATE and all. Going abroad won't give you fruitfulness and all. Like some are saying like that.
I don't think so. Remaining in India and preparing for GATE is okay. That's a regular thing that most people will do. Whereas going abroad and doing a 3-year course and then a 1-year internship is something totally different, and it will totally change your outlook to life also, not just a career. So that would be a sea change. In India, you know what you can become. That's also a good option, but this is something which makes you truly international.
Actually, it is very much struggle period. If I remain back, it is very much struggle period. So it is. I have got here in All India rank 10. So many are saying like you should go forward and all.
I think you should take it up. That is my suggestion.
Okay.
You can mail me if you want more clarification.
Okay. Thank you so much. Sure.
Okay. Yeah.
I think the participants have no more queries. If no one has any query, we can go to the next session. Thank you, Professor Pradeep Kumar sir and Mr. K.R. Arjun for this nice presentation. It was so informative and fruitful to all participants. Thank you very much. I invite Anu Ponar, who is a faculty of our department, to invite the next speaker. Please, Anu J. Ponar.
Thank you, Dr. Devi. Am I audible?
Yes.
Okay. So very good afternoon to all. So it's a great privilege to introduce our next speaker. He is Dr. Bivin G. George, and he's currently working as a postdoctoral fellow at Institute of Geological Sciences and the Polish Academy of Sciences. And he has done his MSc integrated course from Pondicherry University and pursued his PhD from Physical Research Laboratory, Ahmedabad. His research interests are in the fields of isotope geochemistry, Precambrian geology, and sedimentary basins of India. He has published many papers in journals of national and international recognition. And today he will be delivering a talk on the Proterozoic eon and the various events associated with that particular eon. And with this, I welcome Dr. Bibin to deliver his talk. Sir, please.
Okay, thank you very much. Can you hear me, or is it still?
Yes, Bivin, you are audible.
Okay, so I'll share my screen.
Yes,
then.
please.
Okay. Is it visible now?
Yes, Bivin, it is visible.
Okay, yeah, hi.
Yeah, hello.
Hello, yeah, good afternoon, everyone. So you have heard about the various career opportunities in geology, like whether you want to get into a job as a geologist or get into a research field. So I chose the second one. I wanted to get into research and want to try and see what all mysteries of Earth we can really understand. So I did most of this work in PRL when I was a PhD student, and most of these results are from there. So I plan to give you a brief introduction, or like what are the major events which happened in Proterozoic period, and that way I hope to excite you in some way, so that some of you at least will try to take up these topics. So it's mostly in an informal way, so you can stop me and ask questions in between. So I don't have any problem with that. So, okay, so let's start. So the Proterozoic period, if you look at it, it is probably the largest part of Earth's time period. So if you look at it, you see the Earth formed around 4.56 billion years, and the first two eons, like Hadean and Archean, which are mostly 13 and 33%. And after that, there is a you see a huge change in the scope of things. Like at the end of Archean, around 2.5, you can see large-scale craton formation events, like the stable cratons are formed. And after that, things were pretty much smooth for quite some time. So Proterozoic encompasses that time period when things were not as turbulent as Archean or Hadean. So it started around 2.5 billion years and ended around 541 million years. Okay, so it encompasses around 43% of the total time period of the entire Earth. Okay, so if you look at the major events which happened in Proterozoic, okay, so the first one was an oxygenation event at the beginning of Proterozoic. So around 2.3, 2.4, the atmospheric oxygen levels and ocean oxygen levels have increased quite highly. Like if you look at before Proterozoic, the oxygen levels in the atmosphere and ocean were quite low. If you look at the x-axis of the first figure, A, you can see it is like the starting is around 10 power minus 5. So it is only 0.0005% of what was the modern level of oxygen. So this was the initial stage or state of oxygen on the Earth. And sometime in the beginning of Proterozoic, it just increased quite highly. Like it has gone to modern levels. If you see the blue, the green, the curve, and it has that particular event is called as a great oxygenation event. So it's mostly, it is attributed to these cyanobacterial blooms, which produced more oxygen that can be consumed by our reducing environment. So this created an imbalance which left a high amount of oxygen in the atmosphere and ocean. So this was just a one-off event, and subsequent to that, the oxygen levels had again fallen down. And for nearly 1.5 billion, it has fluctuated quite a lot, going up and down. And towards the end of Proterozoic, again, the level has risen to the modern levels, and it has remained much the same for the rest of the period. So this was a major event which has happened in Proterozoic, and from a geological or from a cratonic or continental crust or formation point of view, there were a lot of supercontinents which was formed at that time. So you see or hear names like Columbia, then which formed around 1.8 and disintegrated. And subsequent to that, there was Rodinia, which was there towards the end Proterozoic. And the Proterozoic ended with formation of Gondwana land, which is much more familiar to us. So these supercontinents formed and they dispersed and new continents formed. And this was a kind of thing which happened throughout the Proterozoic. And not only that, there were some more changes which were happening from a climatic point of view. And those were large-scale glacial events, which are known as snowball earth events. And it again started with the Huronian glaciation. It's named after the place where it was first recognized. And that is, you can see the number 4 is the time frame of Proterozoic, like Huronian glaciation. It was there for a large time, and it was a huge glaciation which covered the entire Earth and has wiped off most of its life. So I'll talk more about it in the subsequent slides. And then there was a period in the Proterozoic, mostly in the Mesoproterozoic, where nothing much has happened. People call it the boring billion. For 1 billion years, nothing really happened interesting in the Earth from a climatic perspective. And towards the end of the Proterozoic, again, these glacial events started happening. There were 2 big snowball earth events called the Stottian and Marinovan, and a small glacial event called Gasquias. The first 2 were a really big one. They were called the snowball earth events, and the last one was not as big as the other 2. So, and at the end of these glacial events, you can see that life has started evolving very prolifically. What we see as a Cambrian explosion, if you see the last figure, things have started, like you can see evidence of life from around 3.8 billion years old itself in the form of stromatolites. And things have been kind of slow for quite a long time. And suddenly at the end of Proterozoic, it's just life everywhere. So what really happened during that period of time, which has influenced the Earth so much, and the life has diversified so much into the present condition. So this is basically in a nutshell what I'll be talking about. It's kind of a broader outline. So I'll explain things in a better way. So what made this, first we'll talk about the snowball earth events. These were unique glaciations. So mostly because they were global in nature. So if you look at the diagrams in figure A, you can see that these events, the figure A is for Paleoproterozoic, Huronian one, and figure B is for this younger one. So the first one, you can see that it has a global nature, like it is discovered from almost all the continents. And the same is true with the B, which has like more and more points, because the rock records are much more preserved when you come into Neoproterozoic. And the interesting thing is that most of these glacial events, they were discovered from low latitudes, that is mostly equatorial latitudes, where you really do not expect to see any glaciers. So if you look at modern glaciers also, they are mostly at high altitudes and or towards the poles. You have Antarctica covered with glaciers, you have Arctic a bit like with icy, but you don't really expect to see huge glacial deposits or glaciers in the equatorial region. It's mostly deserts. If you look at the globe, you can see it's mostly desert, which starts from Sahara till our Thar desert. It's mostly very hot region. So you get to see these glacial deposits in regions which were at the tropics in the Proterozoic. So, and this had a different chemical bearing also on these deposits. They were carbonate deposits, and they had a particular anomalous carbon isotopic values. So I'll explain more about it in the subsequent slides, why this was significant. So the theory was something like this. These discoveries led to something of a very, very compelling theory, which has really taken the geologists for a very, very good joyride for the past 20 years. This main theory was proposed sometime in 1999. So it's called the snowballer theory. And the left side, you can see it's an artistic impression of how Earth would have been in the snowball Earth period. Like it would have been completely covered in ice. So the theory is something like this. Following the dispersal of Rodinia, you have seen the supercontinent cycle. So Rodinia was dispersed sometime in the beginning of Neoproterozoic, and this has left most of the continental mass at the equatorial regions. So once most of the continental mass are in equatorial region, the weathering in these areas are quite high. So the weathering started, and it has started drawing down the entire carbon dioxide in the atmosphere. And generally, when carbon dioxide is pulled out of the atmosphere, cooling happens. You hear all about global warming now because more and more carbon dioxide gets into the atmosphere, and it is increasing the temperature. So weathering is the opposite mechanism of this. During weathering, you consume more carbon dioxide and it gets stored into rocks or sedimentary rocks mostly. So most of these continental masses, which was in the tropics, they were weathered very heavily and carbon dioxide drawdown was happening. And as carbon dioxide was mostly removed from the atmosphere, the global temperature cooled and ice or glaciers started forming in the forming in the poles and started advancing towards the tropics. But generally, when this kind of thing happens, if you look at the modern, our current scenario, started advancing and it started covering the land masses. And the weathering, once it is covered with glaciers, then the weathering stops. So, and the intensity of weathering goes down. But in this case, even when the glaciers started moving down, the intensity did not go down because most of the land masses were located in the tropics. And as a result, it continued and the glaciers had reached near tropics. And once it is very close to tropics, then it seems there is a climatic feedback which is it's not will not be able to reverse. So this positive feedback had caused the covering of tropics with glaciers quite some time. So so that was not the end of it. So once glaciers are there at the tropics covering the land masses and partly the oceans, and then there is no more weathering and the global temperatures had gone down and we are all frozen. At least life was frozen almost. The existence of life was very much towards the end. And then there is only one way to reverse this, that is pumping more and more carbon dioxide into the atmosphere. And this happened in the form of volcanism. So volcanism kept pumping carbon dioxide for a long period of time. And once the atmosphere had enough carbon dioxide and started melting the glaciers, then the feedback had gone in the other way. So the weathering was restarted and the carbon dioxide has raised the temperature to very high levels. And again, the feedbacks continued for some more time and normalcy returned. So this is how the theory explained these unusual glaciers or glacial deposits at the tropics. So this whole theory is known as the snowball Earth theory. And people have been working at various aspects of this theory for almost 20 years now. Okay. So what were the evidences? Like I told you all this story, or the theory, but it all came from some of the physical and the chemical evidence, mostly based on these glacial drop stones. So physical evidence comes in the form of these large exotic boulders. So these deposits were at the tropics during the Neoproterozoic, and they saw these kind of exotic glacial or exotic boulders deposited between the strata. So these deposits are called diamictites because they are mostly of kind of exotic origin. And you might have studied glacial deposits. Only glaciers can bring these kind of huge and exotic boulders. And when they retreat, they deposit these boulders there and they retreat. And the sediments subsequent to that, the top part of this physical evidence you can see is carbonate deposits. So just after this glacial deposit, you see carbonate deposits, which are actually warm. Like you need warm conditions to deposit carbonates. You don't expect carbonates to deposit in a very cold environment. So these kind of things really baffled the people for some time. And then the theory explains the second phase of our snowball Earth, when the volcanoes pumped in and the glaciers melted away, and it was subsequently deposited during the warm weather. Okay, So this was the physical as like evidence which has supported the theory. So there were chemical evidences which mostly came in the form of carbon isotopes. So there is a big negative anomaly in the carbon isotopic ratio. So I'll explain it in the next slide. So how this work? So the carbon, you know that carbon has like two isotopes, which is 13 carbon and 12 carbon. 12 carbon is the most abundant. It is 99% is 12 carbon, and very less amount of 13 carbon is there. So when you measure the 13 carbon to 12 carbon ratio in a sample, it's what is written in the first equation. So the carbon isotopic ratio in a sample is represented in the form of delta. So delta 13C is basically the ratio of 13 carbon to 12 carbon in your sample with respect to a standard. Okay. And simply means or simply explains that your sample has how many more 13 atoms or less 13 carbon atoms when compared to a standard. This is the simple explanation for that. So it just tell you that how many extra 13 atoms or how many less 13 atoms are there in your sample. Okay. So how it works, that is what the delta notation means. So the delta value of the carbonates, marine carbonates, are controlled in a different way. Like, so the carbon in our atmosphere, it is mostly derived from mantle. So you can see a small volcano there, and it is the carbon dioxide pumped out from the volcano is of the ratio -6. Okay, -6 is the delta value of the carbon dioxide that is coming from the mantle. Okay, mantle is a huge reservoir of all this carbon dioxide. So it gets in there, and once it is in the atmosphere, the biology or the plants and the biology or the life takes up carbon, and when life takes up carbon, it has a specific thing. It prefers to take 12 carbon instead of 13 carbon. Okay, so as a result, what happens is that biological material tend to have more of 12 carbon, or biology prefers 12 carbon with respect to 13 carbon. Okay, and the rest of the carbon is there, and which eventually goes through various cycles and get deposited as a limestones or marine carbonates, we call it. They are basically limestones. Okay, so there is a balance which maintains this. Okay, so if at present the value of marine carbonates deposited, the delta value is around 0. Okay, and biological material has very high negative values like -20, -25, -27 and all. Okay, so this balance is maintained like that. So what happens when this balance breaks? Let's say there is a mass extinction event. So there is no biology. So this is exactly what happened during a snowball Earth episode. So the biology was nearly non-existent. So as a result, the marine carbonates, which deposited subsequent to the glaciation, it inherited this 13 carbon value, or delta value, which is coming from the mantle directly. So there was no biology there anymore. So there was no fractionation or no changes to the value, and you can see it as a -6. So this is exactly what happened in our glacial event. So if you look at the chemical evidence, you can see from a normal high biology system where biology was really active and a lot of carbon was getting pumped through biological systems, you can see the delta value, which is in the x-axis, it is going to it's going to around 5 8 and all, and suddenly it has started going down, and it has gone to -5, which was like during the glaciation and subsequent to the glacial event. So this kind of forms a chemical evidence that there was something huge, some big event happened, which has really really made our biology stop, or there were like kind of near extinct. Okay, so these were the two evidences which people have presented to argue for this hypothesis. Okay, so I told you about glaciations, and then after that, so subsequent to the last glaciation, or the last major snowball earth event, you see life has started evolving very rapidly. So which we call as a Cambrian explosion. So within a short period, like from around 4.5 billion, or like let me take 3.8, when the first or when evidences of algal life was there, and for nearly 2 billion years nothing really happened, and suddenly at the end of it life started diversifying in all sort of forms, and within the last 500 million years our diversity, I need not tell you this, like diversity has reached to human level or our level. So within a short period it happened. So what really connects all this? So you can see this is the oldest stromatolites. This is around 3.8 billion years old. Like you can see these are stromatolites, you can understand, right? Like these are algal colonies which trapped sediments, and then once they died, these structures remained there. So these are kind of evidence that there were life or algal life was there during that time. So that is what is the importance of stromatolites. So these are from 3.8 billion years, and there are some more evidence. Some people refute this claim and some argue for 3.5. So those are specifics. And there was these were mostly single-celled organisms, or even less than that. And then around 1.8 or 2.1 billion year end of fossil record, where this is called Griffania. These are coiled organisms, and they were also just eukaryotes, what they call us. And it's slightly with the cell membrane and all these kind of biological things, slightly advanced than these algae. And towards the end of the Proterozoic, which people call as Ediacara, which is just after your last snowball earth event, that is around 635. So after that, you can see life. These were animals basically. They were there for some time. So 3 and 4 are Ediacara and fauna. So one is called Sprigina and the other is called Dickinsonia. So these were the Ediacara and fauna. So soon after the glacial event, one starts seeing these kind of fossils. Okay, and the middle one is there is an artistic impression of how life would have been in the Ediacara. This is an artistic impression, not an original photo. So you can see Sprigina and Dickinsonia and all there in the artistic impression. So these life forms were there, and then they got extinct, and suddenly in the beginning of Cambrian, you start seeing trilobites. Okay, more the organisms with the hard body parts and things like that. So the life evolution started with these smaller stromatolites and to eukaryotes and to Ediacara and fauna and their extinction, and suddenly you see hard-bodied animals. So this whole thing happened in the Proterozoic. And within once you start seeing the hard-bodied animals, within short period of time, evolution has moved quite a lot forward. Okay, so was Earth preparing for this evolution during all this time? This is a thing which people have been investigating. And was the glaciation somehow assisted all this? We do not know. So these are some of the outstanding questions which people have. So one of them is okay. So one of the main questions people ask is did these snowball Earths or these global glaciations trigger the evolution of life in some way? Okay, this is one question. Second is what really is the reason for these glacial events? It is kind of understood now, but still there are a lot of scopes for more theories. And what were the temporal extent of these glacial events? How long we were under a snowball Earth, which is also evolving with more and more dating and all. And so what were the environmental conditions during that time? We know it was cold, but what is there more than that? Okay, the ocean atmosphere, or how was it? And what was the global oceanic conditions? Because during that time, life was mostly limited to oceans. And how did life survive through all this? So, and these are some of the significant questions what people try to answer or understand. And what was the role of tectonics in all these things? Like when I told you about the story of snowball Earth, I told how all the continents were nearly equatorial at one point. So more work on paleogeography and the tectonics of that time helps you understand all these things. So these are some of the outstanding questions which people are still working on and trying to understand in a better way. So where was India or Indian subcontinent during that period? So we were also part of most of these supercontinental cycles. So first figure is where India was during the Columbia. So paleomagnetics put us around 30 degrees or slightly between 30 and 60. And we were again part of it. And where were we during Rodinia? It was around 900 million years. We see that India was still part of it. And again, at part of, we were all the black circle there, which is showing the position of India. It was mostly equatorial. So that means between 900 and 540, when these Neoproterozoic glacial events happening, India was mostly closer to all these continents, part of these continents, and moreover, we were in the tropics. Okay. So where do we look for such kind of evidence or the events, the glacial events and other things, whatever I talked about Proterozoic, such kind of evidences, where do we look for in India? Okay, we have plenty of sedimentary basins of Proterozoic age. You might have already studied about Vindhyan, Marwar, Chhattisgarh, Kadapa, Kurnool, and Kariyar, all these major Proterozoic basins. They are collectively called as Purana basins. Okay, so most of them started sedimentation around 1800 in some of them. So we don't really have a sedimentary basin which extend to the beginning of Paleoproterozoic when the Huronian glaciation was going on. So these Purana basins do not extend up to there, but it started slightly after that. And but there are other rock records which extend up to there. And it kind of ends somewhere in the Cambrian. In some of them ends in Neoproterozoic or even Meso. So all these are largely undeformed and unmetamorphosed sediments. So we can study them or we can look in them and try to explore it and understand or find evidence for any of these events in Indian subcontinent. So this was the idea. Okay, so to complete the story, I'll just briefly explain about one such attempt we made in Marwar Basin. Okay, So Marwar Basin, you can see it started around 752 after the Malani volcanism, and then it had a time frame continuing up to 540, 520 into the Cambrian. So it's a kind of Neoproterozoic and Cambrian. You have rock records of that in the Marwar Basin. That was the reason which we went into there. And what did we find, or what were the reports? Or so you can see the stratigraphy there. Like it starts with it is deposited above a Malani volcanics or a volcanic suite, and there are boulder beds above that, and then it is sandstone formation, and after that there is a huge deposit of dolostone and limestone, carbonate deposits. And once you move up, it is all sandstones.